Hey all, what is up? It is Kristen, and today I'm going to have a video for you guys on how to do multiple file compilations with multiple classes to create an executable file. So we're dealing with two classes where the classes interact with each other in a way where you have maybe like a primary class and a secondary class that in some way is part of the larger class. And what we're going to do today is we're going to look at an example with a class called fruit and a primary class called basket, which is going to contain fruit objects. So the first thing I want to point out is this is our txt file over here. We're going to be dealing with some data where we have 4 different types of data on the line that represent the private variables for our fruit. So each one of these lines is going to be all of the information for one piece of fruit. And on a side note, since you might have noticed my interface is slightly different in this video, I am working in the compiler called Atom. So if you're interested in using this particular interface for your compiler, check out Atom. And Atom actually compiles through the command prompt. So I'm going to be doing everything through G++ commands here to create my files and check for errors. And we're actually going to do some debugging in this video to try and go over like what it's like to actually fix code with multiple file compilations. And as you can see here, this is very similar to your bash terminal. In fact, it's the local version of the bash instead of on the cloud, so I can access files within my computer using the command prompt. And I've got some files stored here, so I'm in my correct subdirectory folder for all of my class information here for this example. So what we're going to do first is we're going to generally go over the classes. The fruit class is going to contain some simple attributes to describe it using these private variables. We're going to have our constructors, we're going to have our setter functions for our private variables, and our getter functions, which I have put in here. And of course, because we're dealing with header files, right, we have our if not defined and defined statements. I'm using strings, so I'm including a string, and to make it easier on myself, I'm using namespace. Realistically, you should probably try and work without using namespace in your H files. It is good practice to not include it. The other thing to note is that when I am declaring all of my public functions for my class, I am only passing in the type of the variables needed to make these functions work. I can go about actually naming those variables in my implementation file, so that way I only have to name them once, and this is actually a more efficient way of presenting a blueprint for your class. It doesn't matter what these are named here as long as you're named here. So to go into the implementation file, we have our includes. I'm including the H file here, and of course the default constructor is just basically doing its job by setting everything. We have an overloaded constructor. We have some setters along the way, which are taking in some new values and updating the private value with that new valuable piece of information. And then here we have our getters, where we're just returning our private information. If we move to the next class, we're going to look at the overarching class for fruit. So this contains the fruit H call here to link it to fruit H. So basket is using fruit, and you can see here that we have an array of fruit objects. This is very similar to an array that would be declared of this type. They have the same kind of logistics here. The fruit, which is the class name, takes the place of the type for this array. So what we're doing here is we're declaring an array of fruit class objects, and we're calling it basket, and we're going to give it a static size of 5 in this example. And we've got our constructor and a couple of built-in functions for doing some file I/O. So what we're going to do with these functions is actually use our fruit class built-in functions, because when we include our H file for our other fruit file, for our other class file, we have access to all of the public functions which are part of fruit.cpp and fruit.h. So we can use those in our file I/O and for any of other functions inside of class basket. Okay, so I just saved everything. Let me move over to a couple of these functions here, the implementation file for basket, and then I'll show you the driver. So of course I'm including basket H here in both basket CPP and in my fruit driver. And you'll notice that since basket is the larger class that is including fruit, I don't have to include fruit H here, I just have to include basket H, and the same is true with my driver, because basket includes fruit, automatically fruit is included in the driver. So to go through the list of functions in our basket class, we have a split function, which is very similar to what you've probably seen before in some of my videos. And in this particular split function, I'm just setting it as a void because I'm not concerned about keeping track of the number of things split from my function. So it's a very default split. It's just doing its job. It's updating the string array with the parsed objects, or the parsed pieces of information that will become objects. I have a constructor which is calling my fruit default constructor. So this is a constructor for one class, which is calling a constructor for another class. And in here, I am setting the object array for basket at the iterative position equal to a default object from this. This is the same thing as saying that we're going to declare some object here, call it new fruit, and then set basket I equal to new fruit, right? That would be the exact same thing that we're doing here. We're just doing it in one line of code by just calling this and catching it in that location. In this particular function, this is a read file function, so I'm reading in the fruit objects from my txt file in this function. It takes in a file name, and it's going to parse this information and store it. So you can see here that I open a file stream, I declare a file stream, and I open a file stream. I check to see if it's open. I have a return statement if it doesn't. This is a void function, of course. So all I'm doing here is I'm just returning because there is no return value. I have got a couple of variables here that I'm going to use to parse the line. I know that there are 4 pieces of data on the line. I've got 2 strings, or 2 names, and I've got 2 integers. So what I'm going to do here is I'm going to split into a size 4 array based on the number of pieces of data on the line. I am doing the same thing here where I am setting up a fruit object. I am then setting that equal to my parameterized constructor. So I'm passing in all the information from the split array from 0, 1, 2, 3, and 4. And that's coming from after the split comes back. So the moment that this line executes, the array here is going to be filled with all the information split up from each line of the file as we go down it. So here, after new fruit is catching the object that's created by the parameterized constructor, we set new fruit into the basket and continue on our way. I'm again, of course, making sure that even though I have a void function, no matter what, because we're doing file I/O, I'm going to close this function once I'm done with it. I have a standard print function down here that's just going to access that array of objects, and I'm going to use some getters, which are built-in functions, built-in methods, the accessor functions, which are going to grab the information that we store there just to make sure that we're actually doing it right. So in our driver file, we've got a couple of standard includes. We're doing fstream, so we're going to do that. Actually, as long as we're doing fstream here, we don't actually need it here. I think I was actually going to do that originally with that in my driver, so I'm going to take that out because we don't actually need that here. And of course you can see here that I'm including basket H because basket H is including fruit H because we've included that within basket H. So what I've done here is I've got a main, I'm declaring a basket object. I have set my file name from my file here where fruit.txt resides, and I am going to call a couple of built-in basket functions. So I call .readFruit on my fruit object. So that starts off the process of calling my built-in readFruit function. And then I'm going to print the basket once I actually have some stuff in the basket from readFruit. So I've left some intentional bugs in the code here, and we're going to compile this through the command line, and we're going to debug it here together on the computer. So once I pull up the G++ here, if you want to pause the video and kind of take a guess as to what is causing the compilations here to happen, feel free to do so. Okay, so the first thing here is that I am using G++, and I am going to actually, let me show you what's in my directories. So I'm just going to compile this without actually keeping the command saved. So what I'm doing is I'm using D++, I'm spacing, and then I say minus std equals to C++11 to compile at the standard version of C++11. I'm then going to list the names of the CPPs that I wish to compile together, which is my basket, my fruit, and my driver. Okay, so this is our error output from the bash. So once we compile and we know that we're linking together correctly, we're going to get linking errors potentially. And this is what those look like. So the best way to go about these is to figure out where your line that you executed the command was first. Then go here to your first error message, which is going to give you the file that it's coming from and the line number. So here it's saying that there's a problem in the basket CPP at line 55. So the first place that I'm going to go is basket CPP. And looking at line 55, looks like we have a problem with our call to create an object, or to call the overloaded constructor. So let's see here. In member function readFruit, no matching function for call. No matching function for call. So that means that the function that we're calling, what function are we calling? Well, we're calling the fruit function, right? We're calling this function right here. So it says there's no matching function for call. Well, let's make sure that we actually set that up. So, well, is it here? Yes, it's here. So is it declared everywhere? Well, let's check here. Ah, it looks like we need to add that in here. So that's definitely a problem, is that whenever you have something, you want to make sure that it's declared not only in the public section of your H file, but that you've also implemented it in your implementation file as well. So that should clear up that error. Let's go back and save that and try and recompile again. Well, it looks like we've got a couple of lesser messages. We kind of cleared it up a little bit. So this says we need something for, it looks like it still has a problem with 55 from the same file. So, are we doing something that we're not supposed to? What else could be causing this error to show up? So it still isn't recognizing our function call. It looks like something is going on here. So you can see here that there's an arrow message here, and it looks like something might not be going on with this. Well, if we look at the txt file, we know that we've got two pieces of information which we could store automatically here from the temp array. And we have two integers which we need to convert. Oh, and that's it. It looks like this particular function requires two integers or a boolean and an integer. So let's see here. We need to convert that so that it's recognized as a number instead of as a string. So that clears that up. Let's try and recompile again. I just saved. I'm going to go ahead and compile again. Looks like we're getting a couple less error messages. And it looks like it's now asking for a primary expression before token. So let's see here. Oh, it looks like we forgot, yes we did. We forgot a parentheses on our function. So don't forget to keep track of your parentheses if you have multiple parentheses. So we recompile again. And let's see here. Let's see. Primary expression before token. Well, I'm going to come back to that one. Maybe I'll think about it in a sec. So the next one on my list, if I ignore these for a second, I'm going to come back to that error. The next one is in the driver. The driver is having a problem with line 9. Line 9 here, oh, it looks like instead of calling it basket, I've called it baskets. So I've just mislabeled the type of the object that I'm creating, so it should be a basket type object. So make sure that that is the same name, spelled exactly the same way as the way you've declared your class. So let's go ahead and recompile and see what else we got. We still need to fix. It looks like we might have, let's clear again and see if that actually did it. It did. Okay, so we now have our executable file here. So that means that we can compile, but looks like nothing's happening. Okay, so, okay, well, we created a basket object. We stored a file name. We read in all the data from that file, and we were supposed to print it, but it doesn't look like anything got printed along the way. So let's see what could have happened. Let's see if we can add a print statement and see if we can get something to happen. Okay, so that gives us a piece of information. Something's going on that's keeping us from getting to our print function. Something is getting to these cout statements here, but we can print up here. So because we can print here, but we can't print here, let's see if we can't print here. Let's try adding in a line of text here. So this is kind of like a sandwich kind of method of debugging, where we're putting something on top and something on bottom and seeing if we can print both things. So top line here, this print statement executed. However, this one did not, meaning that something along the way stopped the code. So we might be seg faulting or causing something to happen along the way. So something happened when we created our basket object. So if we go here to basket H, right, we have declared this here. And if we go here to the basket, so we're looking here inside of our basket object. Here's our basket function. This is what we call basket myFruit. It looks like here we initialize size correctly to 5. However, in this line right here, we have segfaulted from going over the size of our array. So because our array starts at 0, we are actually exceeding that by 1, causing a segfault. So this particular for loop was segfaulting, and so this line of code was causing none of the code below it to execute correctly. So I save that. Let's recompile. Okay, so now we've got output. So it looks like our first statement executed. Our cout on line 10 executed as well. Let's add in a thing here and see if, let's add in the rest of these print statements and see if they executed as well. Okay, so it looks like we are getting some of the stuff that we wanted to print working. So we printed this line. We printed the read executed line as well, but we did not print the line after the print basket function. So something happened along the way to stop us from printing that. So we'll have to check that. And there's also something going on where our print function is printing, but it looks like it might not necessarily be printing what we want. So now we need to figure out what's going on with that. So the first thing I want to do here is I want to check read fruit. Maybe something happened, or maybe let's actually start with print basket, because I thought that there might be something going on with that. Oh, this is a definite example here. We're doing the same thing here. This is an obvious example of a segfault. That's not going to work. We're going to have to set it so that it terminates on the last position in the array. That looks good now. So let's try and recompile again. Looks like we're no longer segfaulting. So that means that the rest of these lines of code actually got printed. So now we're actually printing everything from the main correctly. However, we still got this problem where it looks like something went wrong along the way when we were doing maybe file IO, or maybe when the printing happened correctly. So it wasn't because of anything that we were doing syntactically. So this has to do with maybe assignment. Maybe something didn't happen along the way in the file IO function. So I'm going to go to read fruit and see what's going on there. So I'm gonna, when I have to do this, a lot of times what I'll do is I'll say, okay, I know this is a void function, and I know that this is what it's taking in. The next line is I'm going to tell myself what it does line by line. So we open an input file stream. With these first two lines, we declare in file, then we open file name. We check to see if the file is open, and we have an else down below, and we have a close down below. So if the file is open, we're going to go in, we're going to declare an iterative value for keeping track of the line number. That sounds good. We're going to go in here and declare a line to temporarily store the line of information in the file. We're going to declare a temp array of the size 4 for the number of pieces of data. That sounds good. We're going through the while loop. We're using the file stream to parse into a line, and we're calling our split function. And once the split function executes, it looks like we'll create a fruit object. We're going to make that fruit object into a fully realized object by calling the constructor on it. And we're going to assign it here to some array position at I, and okay. So it looks like Kiwi was actually stored. Well, Kiwi is the last piece of data in the file. So that means that this was actually stored in here at some variable. Well, what got printed first? Well, Kiwi got printed first. Kiwi is at position 0 in the array if we're starting the print function down here at 0 position. So that means that we never actually stored anything past that. So we only stored Kiwi in the first position. Well, that means that we never incremented I. Oh, that's what it was. We needed to increment I in order to continuously access the array for basket to store the fruit. So we only stored one fruit, and it was the fruit on the last line at the 0 position of what I was initially stored to, or declared to, and initialized. So let's see, what else do we have here? Let's see what else our compilation is going to throw at us. Oh, wow, it looks like we got everything. Let's double check our output. Okay, so our first print executed. So our next print executed, so that means that declaring our object worked. Read executed, so that means our file IO worked correctly. And now we're printing everything from the basket exactly correct because we're asking for the type of fruit and it looks like the number of fruit. So let's double check that. It looks like we're grabbing the fruit name and the number of fruit stored in that object. That is awesome. And we're also getting our output for the bottom of the function from things for fruit. So cool. Thanks, you guys. That's the end of what I've got for you this time. I hope this was informative, and good luck with your upcoming projects.